Yeah, so welcome everyone. As Sven already said, we will try to answer the question if you need a service mesh, and if so, maybe which one, or what are the differences you should look at when choosing a technology. Just a few words about us. I'm Hanna. I work for INNOQ as a developer and a consultant. I'm mostly in the space of DevOps, Kubernetes, service mesh, all of that. And I have Eberhard with me.
Yeah, so thanks for the introduction, Sven, and I'm happy to be here. So my name is Eberhard Wolff, and I'm also with INNOQ. I mostly work on architecture, actually. So I focus on the business side of things, technology, software architecture, and how to put it all together. I'm a fellow. I've written a few books about microservices, for example, and I'm glad to be here.
Yeah, Eberhard and me, we also wrote a book together. A tiny book about service mesh, which we will link at the end. Yeah, so to start with, I think it's important to briefly talk about what a service mesh is, technology-wise, and why it was invented, so what problems it tries to solve. To start with the problems, I think you are all aware that microservices are distributed systems, and being distributed systems, they are a complex architecture, and if you introduce such a distributed system, there are a lot of challenges to the integration of microservices. So, for example, you have to route the requests between the microservices instead of just calling a method or function. And there's also service discovery to do. Then there's also the decision of when you will stop a request. So what is your timeout limit for this call? And then there's also the decision of if you want to retry and how often you want to retry. And also connected to that, we have circuit breaking, which basically means you exclude a certain endpoint if it behaves unexpectedly for some time. Also, I think that's the major challenge in microservice integration or networking is encryption. So you want to make sure that whoever is inside your network cannot see or manipulate what happens. And then there's authentication and authorization, which can apply to service or even to user authentication. And if you have microservices, you need to find out what's happening in your system. So you need metrics for that, dashboards, observability tools, because there's no way of knowing if you don't have these metrics, what's going on. And finally, there's logging. There's a challenge of logging, so you need to get all the logs from all the services and look at them all together. That's only a few of the challenges that you are facing when you're building microservices, and that's why service mesh was invented in the first place. So if we look at the architecture of a service mesh, then we still, of course, have the microservice applications in the application layer. And instead of changing our microservices and put all the features inside of those, we add a proxy in front of each microservice that solves many problems around service networking and many of the features I just mentioned outside of the service. And the proxies intercept all the traffic that's going in and out of the service. And all the proxies together are called the data plane. The term is also common for other technology, but it also applies on service mesh. And the counterpart of the data plane is the control plane. And just like the name suggests, it controls the proxies, which means that it distributes configuration. So it distributes new timeout configuration or routing configuration. And the proxies also communicate to this control plane in sending metrics. So they have knowledge of all the traffic that's going on and they can provide metrics about that to the control plane. So attached to the control plane, we can add infrastructure, and usually, because most service mesh technology is based on Kubernetes, usually it's the Kubernetes API that the control plane is connected to, but there's also other infrastructure services that you can plug in, such as monitoring tools or tracing tools. So that's the architecture of a service mesh, and Eberhard will tell you some more about the implementations that there are.
Yeah, so, and we are going to start with the two most, let's say, famous implementations, which are Istio and Linkerd. And if you look at them, they have actually quite different approaches. So Istio, on the one hand, is a project that has been started by Google, IBM, and Lyft, while Linkerd is a project that is run by a company that provides services around Linkerd. Istio has an emphasis on the number of features. It's highly customizable, while Linkerd tries to be as usable as possible and is also optimized for performance. So there is a very different trade-off here. Istio uses the Envoy proxy, which is not that surprising because it is another project that Lyft originally started. Linkerd has its own proxy that they implemented specifically for Linkerd. And with Istio, so the ingress traffic is traffic that goes into your Kubernetes cluster or microservices system. And with Istio, there is a custom concept inside Istio to handle that traffic, while Linkerd relies on the features that Kubernetes has in that regard. And it would support any ingress controller that Kubernetes might support. And talking about Kubernetes, so Linkerd is specifically just for Kubernetes, while Istio is optimized for Kubernetes, but it also supports other platforms. So there are very different trade-offs here, but there is even more, which Hanna is going to talk about.
Yeah, so if you look at service mesh implementations, there is much more than even I would expect to be. So we don't only have Linkerd and Istio, which are the most popular ones and also the oldest ones. We also have Console, which is currently like newly branded as a service mesh, which was a service discovery tool before. And then we have AWS App Mesh, which is available on AWS and also integrated, of course, with the AWS service landscape. Then we have two service meshes that are built by companies who build API gateways or edge proxies. So Traffic is an edge proxy, and it also has a service mesh, which makes a lot of sense because it's similar challenges that the technology solves. And these companies have a lot of experience with these challenges. And Kuma is built by the company behind the API gateway Kong. So it's a similar situation as with Traffic. And finally, the newest service mesh implementations are Open Service Mesh and Nginx Service Mesh. Open Service Mesh is built by Microsoft. So you see that there are a lot of major players around, like Google and AWS and Microsoft, that are investing here. And also Nginx has built their own service mesh. Many of these service mesh implementations have implemented parts of the service mesh interface, which is the API definition that was also published by Microsoft and also other companies. And the idea behind that is that you have a common API for the features of a service mesh, and you can exchange the service mesh underneath. So you are implementing your configuration, or you are writing your configuration against this API, and can exchange the service mesh. But also you could build services on top of a service mesh, for example, a dashboard. And this dashboard could be compatible with all the service meshes that implement the interface. colleagues and us, Eberhard and me, we have built a website where you can compare those service mesh implementations, also how they implement the service mesh interface, for example, also linking documentation. What you will basically see is a table just like this. It's a huge, much larger table than this one actually, but this might be a good resource for everyone who's looking at this topic. Yeah, now Eberhard will start talking about the service mesh features.
And actually, there are quite a few of them. I mean, if you think about it, it's just about wiretapping into the communication between those microservices, but that means that you can do a lot of stuff. So let's start off with features around security. Around routing. So with routing, one thing that you can do is, if you have a service right here, and you want to do some A/B testing, so that service should talk to another service, and there are two alternative strategies that this service might use. So maybe it's a recommendation service, and there are different algorithms to recommend things to some customers. You want to test both implementations, then you can do routing, and you can say, okay, we are going to route some of the traffic to service instance 2A and some of the traffic to service instance 2B. So for example, 90% goes to A and 10% goes to B. And now we can see which one of the two is the better one because we get some metrics like the revenue, and then we see which implementation of the recommendation service is the better one. And we can do the same thing for canary releasing. Canary releasing means that we release a new version of, in this case, service 2, and we look at how good it actually behaves in production. And we start off with 10%, and then we increase the load 20%, 30%, and so on. And that is something that you can do by wiretapping into the communication and routing it to different instances. What you can also do is you can do traffic mirroring. So here is the service, and it talks to some service in production. Now there's a new version of that second service, and that's in staging. And now you want to see whether that one actually behaves correctly. So you just take the production traffic and route it to the staging environment 2. And in that way, you can easily figure out whether that instance in staging behaves correctly, or whether you should rather go and fix some bugs instead. So those are the features concerning routing. And Hanna's going to talk about the features concerning resilience.
Yeah, so the second group is like about resilience. There are quite some features around this topic of resilience. So the first, and I already talked about it, is timeout. So if the service you are talking to does not respond in time, you can stop the request. You can configure the proxy to stop the request actually, and you can also configure automatic retries, and you can also limit these automatic retries to specific paths or HTTP methods, for example, in some service meshes. And you could also configure circuit breaking. So the proxy would measure the health of its endpoints, and as soon as it sees that that another service does not behave like it expects, then it can exclude this service instance from the potential endpoint list for some time. So this is about the typical resilience features, but there's also chaos engineering, which basically means that you perform some experiments around in your live infrastructure or in your production system, and you are verifying assumptions that you have. So, for example, my service will even if this other service is not available, it will respond, or it will respond with no error, or it can compensate for delays, for example. So what you do is you add arrows to your application or delays, and you measure the outcome. So afterwards you know if your assumptions were right about the fault and delay behavior of your services. And this is something you can add with the service mesh. So you don't have to add error to your microservice instance, for example. You can just configure the proxy to behave like an errorless service. And Eberhard will talk about security now.
Yeah, so concerning security, there is, again, quite a few features that a service mesh can bring to the table. So first of all, there is encryption. So if you have two microservices, the communication between the proxies can be encrypted, and you can use MTLS for that. So that's mutual TLS. So it means that both microservices authenticate to one another. So you can actually be sure that microservice 1 is actually really talking to microservice 2 and not, that there is no man-in-the-middle attack. So that's the authentication part. There's also authorization. So if microservice 1 is allowed to talk to microservice 2, then the proxy can actually make sure that this communication is allowed. While if there is another microservice that tries to access that second microservice, that might fail because there are some roots in the authorization in the service mesh that say that it is not allowed to call that microservice. And you can even limit that to specific HTTP methods. So you can say, okay, this service is allowed to do GET methods, but not POST methods. And it could be limited to a specific path like /customer, but not /order and the like. One additional remark in this regard concerning, well, for example, encryption, you might wonder, what about the communication between the proxy and the microservice? Well, that never leaves any machine and it's not observable from the outside. So it's fine that this is not encrypted and there is no authorization and these kinds, because it's limited to one machine, actually one pod, if you talk about Kubernetes. So next is observability that Hanna is going to talk about.
Yeah, so I believe that the hype around service mesh also lives from the observability part, because it's a very interesting what you can see of your application without doing any changes to your code. So the dashboards that you can see are pretty impressive. And I will show you the dashboard for Linkerd and Istio. So this is the dashboard of Linkerd. So you have a graph of your services. This is a very tiny application. And you also have statistics like the success rates, the requests per second, the performance of the system. Also broken down to paths. And there's a lot more. In the dashboard that I didn't show in the video now, but I think you get an impression of what you can see without, as I said, changing anything in your code, just by observing the traffic at the proxy side and collecting it and building graphs and tables about that. The dashboard of Istio has a slightly different approach. I will also show you a video of that. You have a much more graphical approach. You also see the logs that show that traffic is encrypted. You also see traffic floating. So sometimes you see some bubbles going from one service to another, like here. You can also see requests per second, latency, and request percentage distribution, just as you see in the menu, and much more also. This can be very impressive when you didn't have any graphical or insight into your application. This dashboard is called Kiali, and it's integrated with Istio. I think it's possible that it will be available for other service meshes as well, but right now this is the dashboard of Istio only. So you can see that you get a lot of observability or insight to your microservice application by installing a service mesh. What you get beyond these dashboards is in most service meshes a pre-configured instance of Prometheus, Grafana, and often even Jaeger, which is a popular tracing backend. So you will get an instance of these services with prepared dashboards, and they will collect the metrics that the proxies collect and fill the dashboards with this data. And you can even get this data from the Prometheus instance for your own graphical tool, for example, or for your own Prometheus dashboard. I mentioned Jaeger already, so this means that service meshes also support tracing. So they are many service mesh implementations are capable of sending the tracing data to a backend. What you would still have to do is you have to pass the incoming tracing headers to outgoing requests, but the rest can be done by service mesh. And another feature of observability is access logs. So you can generate access logs since the proxy sees all the traffic. Of course, that's for free for the technology to do. And Linkerd has a different approach to that. It can let you tap into live traffic for debugging purposes, for example. Yeah. So that's about the features of service mesh, and I think it's very important to also talk about challenges.
Yeah, so far we could easily say, well, look, here are all the features, and actually you don't need to change any of your code. You will get all those features for free. So why wouldn't you do it? Well, because as usual, there is a trade-off, and we need to talk about the challenges too. So one of the challenges is that there is some additional configuration that you need to do. So if you have that example of the traffic split, where 90% of the traffic goes to one specific service instance and 10% goes to the other one, well, that might be 10 lines of YAML if you use Linkerd, or it might be 30 lines of YAML if you use Istio. And some people do enjoy, at least I think that there might be some people who actually do enjoy writing YAML, but there are also people who don't really like that. And it might be somewhat cumbersome to do that. There is another thing that I would like to add. Well, if you look at this, the question is, what is the alternative? So it's not enough to say, here are challenges and this is a problem and you shouldn't use service meshes. If you do need those features, you need to come up with an alternative that might be even worse. Then there is the additional debugging complexity. So if some traffic goes into your system, it passes the ingress controller, it goes to the microservice. So the first thing that might fail is the ingress controller and the communication to the microservice. The next thing that might fail is the communication from the microservice to the other microservice. Proxy might fail. The other proxy on the other side might fail. The original microservice might fail. There is the control plane that takes care of all the proxies and configures them. That one might fail. Kubernetes might fail. The overlay network might fail. And also, obviously, the hardware will fail. Some of these components are not specific to service meshes. So obviously, Kubernetes is not something that is part of a service mesh, because a service mesh is typically built on top of that. But there is just more stuff, and more stuff can therefore go wrong. And that means that debugging becomes more complex because you need to figure out what is actually broken, and that's a more complex problem now. Then there is benchmarking and performance. So there is some performance impact there. And what Istio says it's about 3 milliseconds. Actually, I'm quite thankful for that statement because it keeps me from doing benchmarking myself. and it gives at least a rough number, but you need to figure out that there is more. So there is CPU and memory resources that the proxies and the control plane and these things will consume. And what you actually, the latency and the resource consumption that you actually see in production, well, that is something that depends on your architecture and on the traffic that you're having. If you have chatty microservices that talk a lot to one another, you will have a huger impact of a service mesh as if you would just have a few microservices that hardly talk to one another. So you should probably do your own benchmarking and figure out what the impact of a service mesh is to your architecture. And that leads to the next question. Do you actually need a service mesh, and what are the alternatives? And that is what Hanna is going to talk about.
Yeah, so I think this is the main question that a lot of people have, if they need a service mesh or not. And I think the first question to ask yourself is, do you need the features that we just mentioned? And did you already solve them in your system? And are you happy with the way you solve them? Or is there pain connected to these features? And if you didn't solve these challenges, or if there's pain, then from what I see, you have 2.5 options. So the first is to use libraries, just like we did for the last years. The half is to implement it on your own, which I would not recommend. So this is why this is the half option. And the third is to use automation, just like a service mesh. So you cannot compare the features of a service mesh against nothing. You have to compare it to implementation with help of a library or even your own code. So this is the choice that I think you got. But I would like to take even a step back and think for a moment, think about why we actually need all these features. And if you can avoid needing those features at all. Of course, I don't mean not to write software, but I mean to think about architecture maybe a bit longer before just going with the default microservice approach. And I say this because I think we have many options that we might not be aware of. So one way to go is, of course, with synchronous microservice architecture, which is the architecture that service mesh is built for. But there's also asynchronous communication that you can use to prevent the need for example, monitoring or routing, and also resilience. And also, there's also architecture that is not microservice. So you could even think about a very strong modularized piece of software that you deploy as a monolith. And I really believe that this is something that we should think about more when talking about the challenges of microservices. Which leads me to the conclusion that Eberhard will do.
Yeah, so approaching microservices, I think the first question is whether the architecture that you've chosen is an architecture that makes it, well, desirable to have a service mesh. And the funny thing about that is, and that is what Hanna was talking about just in the previous section of the presentation, if you do need a service mesh, you're probably looking at a synchronous architecture with a lot of microservices talking to one another that are quite chatty, because then you have a lot of communication and resilience really pays off, and you can wiretap into the communication, and you have all the observability, and that really means something because you have so much communication. But then you also have probably a lot of problems because A lot of network traffic means that the system will be slow because there's so much network latency. Every incoming request causes a lot of other requests to happen. And it's also probably unreliable because if the network fails or if one of those services fails, then there will be a huge problem. So maybe it would be worth to use an alternative architecture. Then the question is, which feature do you actually need? Routing, resilience, security, and so on and so on. And there are some features where I have a hard time that you imagining that you could do it without a service mesh. So for example, security, in that case, you would need to distribute certificates securely to all those microservices. That's a tough problem. So maybe you want to use the service mesh then, and actually you can strip down service meshes like Istio to just provide that, to just encrypt communication and leave out all the other features. There are alternatives. So you could use some libraries instead. So there are libraries like Resilience4j that allow you to do resilience. So you could use them instead. And then there is the impact on performance, on configuration and so on. And the question is whether you're willing to pay that overhead. If you're interested in more information, there is the service mesh comparison that we already talked about. There is a blog post that Hanna did about how you can be happy without using a service mesh. So that is a blog post that talks very detailed about why you would probably not want to use a service mesh. There are the tutorials for Linkerd and Istio. There is a sample application that we did for both Istio and Linkerd, and it should be pretty easy to get to run it on your own machine. We did an interview with the GOTO book club about service meshes. So that's another good source where you get a video of, I believe, almost half an hour. And last but not least, there is the service mesh primer. So that's this one that gives you a short overview about service meshes. So there, and the ebook is free. So it's about 40 pages, and it tells you everything that you need to know about service meshes. So thanks a lot for having us. Thanks a lot for listening to our talk.